Gray, rain-filled skies seemed to dip into the ocean during the storm last March. Every 3 hours, data analyst Chad Hecht and postdoctoral researcher Allison McKellis pulled out a weather balloon.
We took it out of the package, put it under the spigot, where we can now fill it with helium.
Once gas filled the balloon, Hecht tied off the end and attached instruments that record temperature, pressure, and relative humidity, among other things. With everything ready, it's a short walk to clear the buildings.
3, 2, 1.
The balloon rushed toward the clouds, growing as the air pressure outside the balloon dropped. When it got to be about the size of a school bus, it popped. McKellis says instruments collected data on the way up and on the way down.
Some of our recent launches overnight got up to about 23,000 meters. And so we're gathering temperature data, moisture data, wind direction and wind speed all the way.
That's important because these storm systems have an outsized influence on Southern California weather. Marty Ralph established the Center for Western Weather and Water Extremes at the Scripps Institution of Oceanography.
An atmospheric river is supercharged with a lot of water vapor, and it has a lot of wind at low altitude to push that water vapor along. So it's really a river in the sky, but a river of water vapor.
That river can bring everything from a steady, beneficial rain that can ease the risk of wildfires to damaging rainfall strong enough to cause floods. But researchers don't yet know a lot about the rivers, and that's why the weather balloons are so important.
It turns out the core of the AR is fairly narrow horizontally, and it's hard to get a measurement right in the right spot. So we fly airplanes through them offshore to try to sample that, but we also launch weather balloons occasionally, quite often at the coast, to measure that as well.
And what this research will do, it will allow scientists to better understand these storm systems so that they can predict when they'll happen. They'll be able to say how intense they are, and they'll be able to gauge the impact on land. Those launches last spring at the Scripps Institution of Oceanography Pier are already paying dividends.
We just collect observations that gives us information about these systems, both meteorologically and the physical processes that are occurring that could lead to extreme precipitation in Southern California. And we're also taking that information and assimilating it into forecast models, both globally and nationally, to see if we can improve forecasts with these observations.
An analysis found current weather models fell short, especially when researchers looked at integrated vapor transport,
which is essentially how much moisture is moving in the atmosphere in what direction and how strong. And it was forecasting about 300 units of IVT, or integrated vapor transport, over Southern California, and we were able to observe about 600, so almost twice as much as what was being forecast.
Current storm prediction models also missed a bit on the exact location of the river. Application programmer Brian Kozunuk, who helped launch the balloons, says that's important because forecasters want to predict exactly where those narrow bands of rain will hit land.
Because we had the observations, we were able to see that the models were actually a little bit incorrect with the placement of the AR, and that it actually was further north than what was expected.
Kozunuk says researchers also have balloon launching stations in Orange County, near Sacramento, and a couple of spots north of San Francisco. And the Center for Western Weather and Water Extremes is working with water managers around the state. They hope better storm prediction models will make it easier to manage California's scarce water supplies. Erik Anderson, KPBS News.